did. Like I want you to love me, don't want you to fear me. Let's been through the set, trying to look great for Cherry. But I heard that nigga is snitch. See blue shot, heard he a Vic. Dougie got shot, started shaking his head. Anybody get
oh, I gotta enjoy this.
Let me catch me a mother. Back on my grip, put the beam with his back. I just hope he don't trip. SD get the bulk and I love when I flick. If I see Rippy bitch, put the dot on her wig. Bro, slow down. I think
he's tired, but it's not really cool mind, friends. It's a fire.
I had him tired. Jack on the back of that block, he on time. Try to bless through my block, then I'm fired. Them tires is flat, something wrong with that V. Like if he's been through my block on the tires.
Bro, this is fire. What? Oh, the damn. Bro, alright, so let's get on track. Alright, dude, let's get it. Alright, so we're gonna try to do this. We're gonna try to, not fuck up. Okay, so let me start off with some basic stuff. Okay, so obviously you know what SQL and NoSQL is, right? I'm assuming you know what that means, right? You know what this means, right? SQL and NoSQL, structured query language. So like SQL commands and stuff. You're aware, right? Okay, so first of all, what I'm going to show you is obviously like, okay, so the SQL and NoSQL database, right? So like, have you heard of this thing called MongoDB? I'm just going to call it MB. Have you heard of it? No, right? Then I need quick answers, bro. Vinod? Have you heard of this thing called MongoDB?
Oh yeah.
Okay, so it's obviously NoSQL, right? Okay, so pretty much what I want you to, okay, so let's make this interesting, okay? So there's this first thing called serverless, okay? Serverless means obviously there's no servers, right? So you don't, basically, not that there's no servers, it means that you don't need to take care of servers because it takes care of servers for you. So this is the thing called Lambda, okay? I'm just gonna call it L. And we also have this thing called Elastic Gate, okay? Elastic Gate, yeah, exactly. So Elastic Gate, where is it? Fargate, my bad. Fargate. Okay, not Elasticgate. FG. Okay, so FG. Okay, so in FG, this. Okay, this takes everything in containers. Okay, which means you need to have everything in containers in order. So, for example, like if you have a big application. Okay, let's say I'm just gonna draw like a big guy. Okay, so. Alright, so this big guy. So if it's like a small guy, like for a small use case, obviously you can store this guy in a Lambda. Okay, that's basically this guy. That's me. Alright, that's this guy. Okay, so this guy, you can store that guy in Lambda because it's serverless and it's easy to store. Okay, so this is so both are serverless, except this guy, this big guy. Okay, this big application. Okay, so the size of his basically this. A big application needs to be stored in containers. Okay, so its containers will be stored in FG. Okay, but both are serverless, so you don't need to deal with servers and stuff. Okay, so next let's move on. Okay, so let's move on to so there's different types of scaling. Okay, so for example, there's this thing called on demand, right? So on demand means when you have demand, right, you pay for it. So it's like a pay as you go type of basis. It's a 12-month free trial for especially for people like me who can't afford to pay for any of these services, right? So 12-month free trial, so all these services are like pretty much free for like 12 months. Okay, so it's just to experiment. Okay, so certain services, not everything. Okay, so there's on demand, which means like when you need it, you will pay for it. And then there's also a contract agreement, for example, that's for like 1, 2, 3 years. So when you go for this contract agreement, it's like I think it's called reserved instances, right? So reserved instances, you take it, reserve it for 1 or 3 years. So then you get a discount, like as a thank you sort of thing. You know what I mean? You get the point, right? So I think you got up to that point. What do you think? Do you have any questions?
Yeah.
No, right? Okay, I hope not, but don't worry, I'm gonna upload this video because this is just a free tutoring session. Okay, so don't expect me to be slow. Okay, I'm not a tutor. Okay, so pretty much okay, so there's single auto scaling, so that's something that I'm looking into. So 1 second, what's up with my screen? Okay, so for example, like, okay, so we have these stuff, right? So dedicated hosts. So this is something that I haven't really quite looked into. dedicated hosts are physical servers fully dedicated to you. You can use your existing VM software licenses. Okay, so these are fully dedicated to you. That's the only difference. So let's make a note out of this, saying that, for example, let's say what cloud and dedicated hosts. Okay, so apart from that, we also have so scaling, right? Scaling is obviously like, you know, increasing the price and stuff. So auto scaling. So this is one part that I'm gonna get to at the very last bit. Okay, so let me just go on to load balancing. So load balancing. Okay, so elastic compute is basically this the infrastructure that's going to take care of everything. Okay, so pretty much ELB. Okay, ELB has these three types of ELB. Okay, so first of all, we have the network side of load balancing, so we'll call it NLB, and we have the application side of load balancer, we'll call it ALB, and we have the cloud side of load balancer, which is let's call it CLB. Okay, so NLB is basically you're balancing the amount of traffic that's coming into your network. Okay, this is the application, and you're balancing the cloud. Okay, so pretty much like this is to avoid any like crashes in application levels and network levels, and CLB to avoid any budgeting problems or any of those, you know what I mean? Because the infrastructure is built for bigger things, but it's obviously, you know, like not gonna be favorable if your bill is like $1 million, you know what I mean? So pretty much you can see, so single point load balancing service a single point of contact for incoming web traffic. There's incoming web traffic on top. Let me see. Let's see if this answer is correct. Yep, that's right. Okay, so this thing is kind of slow. Anyways, messaging, right? So we have messaging. So as far as messaging, that means like for example, if you have like a problem with the server, it obviously needs to send you a message, right? So the simple notification system will send you the message, okay? While the simple queuing system will save these messages in a queue, okay? So for example, 1, 2, 3, like that. So the notification system will send you the message as soon as possible. The queuing system will save them as like, you know, like different notifications in a queue, so that way you can individually handle them, right? So this one is instant, this one is queuing, okay? So apart from that, we have containers. So containers are like packages of your whole application. So for example, the dependencies, or it's called dependencies, the I don't know, the infrastructure, so it's the whole application, okay? It's bundled onto a container to avoid to run it on multiple different computers. For example, if you're running it on a different computer, like it's gonna have like dependency issues and all that, right? So we put it in containers. So mainly we use this thing called Docker, okay? Docker, and we use this thing called Kubernetes for orchestration, which means you're controlling multiple different containers. Okay, so for orchestration, container orchestration, you use this thing called Kubernetes. So I'm just going to call it KUB, my bad. So that's what ECS, sorry, where is it? So that's what ECS and EKS means. So ECS is container service, and KS means Kubernetes service. Okay, so containers, multiple containers managed by Kubernetes, like orchestration service. Okay. So Fargate, like I mentioned earlier, we have Fargate, which is obviously this what do you call it, container. So you could store containers. It's serverless, okay, on Fargate. So it's called serverless, okay, serverless, and you can store this. It's serverless, and you can store containers instead of Lambda, okay. So Lambda, the difference is that Lambda is taking smaller applications, but for so Lambda does this thing called event-driven functions. For example, like when it triggers certain events, right? It executes everything. That's something that I need to double check on. But in Fargate, it's always like containers. You know what I mean? So everything is serverless in both of them. But in Fargate, it's like it's containers, right? So everything is like bigger applications need to be in containers. You know what I mean? To be managed. So yeah, so that's that one. Infrastructure and regions. So regions wise, like these servers are like everywhere, right? Everywhere globally. Okay. So when it comes to infrastructure regions, so there are different regions, right? So in each, there are things called availability zones, where there's like one data center or multiple data centers in a certain availability zone, right? For example, like let's say in a certain area, we have one or multiple of these. Okay. So the more the better, right? So obviously we have what else do we have? Infrastructure regions, availability zones, edge locations. So edge locations means, so the infrastructure could be running, so that there's this two types of things, right? So we have the infrastructure of the application, right? And we also have the actual data of the application, right? So you can have the data, right, running nearby a client's server, okay, while you have to have the infrastructure running nearby you, okay. the reason for this is because data, okay, data is obviously like if the closer it is to the client, the data, okay, in a server that's close to the client, the quicker the data will be exchanged back and forth, and meet the client's fast requirements. But if it's the infrastructure can be the AU because it's just the infrastructure of the application, not the actual data that needs to be exchanged back and forth, right? So apart from that, we have provisions. So provisions obviously like what do you call it? Maintaining the whole thing and provisioning. So just like watching over it, right? So let's say, for example, there's 3 ways to really go about this. We have a web management console. Okay, I don't know why my computer is so loud for some reason, but we have a web management console. Okay, we call it let's just call it a web management console. Okay, and we also have a CLI, which is a command line interface. So apart from that, we also have this API. So you can use APIs built by Bezos himself to interact with AWS. Okay, so all of them are used to interact with AWS. Okay, so pretty much interact with the AWS services. So these are the main 3 ways. Okay, apart from that, we have provision services. So let's see what this is about. Cloud formation. So cloud formation. Okay, cloud formation is basically CF. I'll just call it CF. Okay, so I don't know why my computer fans are so loud. Okay, let me just close this tab. Okay, so now CF. Okay, CF, and we also have this thing called Terraform. So let's just call it TF. So TF, both of them have this thing in common, which is called infrastructure as code. So let's just call it ISE. So the difference is that this one, okay, this one has its own programming language, a scripting language, and this one follows YAML and JSON. Okay, YAML and JSON. So they're very similar. They're not the same, but they're very similar as far as scripting goes, right? So right here, JSON. Okay, this is JavaScript object notation. So what we do here is we have Terraform, right? So Terraform provides infrastructure as code, which means you give it a certain set of instructions for things like CI/CD, like a CI/CD pipelines. That's like continuous integration development. So like when you're deploying something, you want it to sort of merge in a certain manner or things like that, right? So in different use cases, it will be different, right? So you're basically writing a script, okay? So you're just saying yes, 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 do this, do this, do this, in order for a certain pipeline. So we call it a CI/CD pipeline, a certain way you want it to sort of go about a life cycle, right? So what happens here is that this one supports, so Terraform supports many different types of cloud providers. For example, AWS is one of them, GCP is one of them, right? And what was it? Azure is one of them. That's by your boy Bill Gates, right? So all these, right? Terraform has its own scripting language, so this is different from JSON and YAML. Okay, so what we do here is with cloud formation. So once again, it's basically ISE, right? Like I said. So we have 2 tools. So we have the Elastic Beanstalk, right? Elastic Beanstalk, and we have a cloud formation, which is the other one. So let's see if this answer is right. Yep, there we go. So if I just submit this, it's kind of slow, but you get the point. Okay, so pretty much what's next? So Elastic Beanstalk, this is something that I kind of forgot. Okay, so it's a cloud orchestration service. So it's pretty much used to handle multiple different multiple cloud environments. Is it? Elastic Web Infrastructure Management Service. So Beanstalk handles deployment and scaling for web applications and services. Helps automatically manage AWS services, set up configuration, scaling, and provisioning. So pretty much what it does, from what I can understand, is that it manages cloud services. So let's make this a question. So let me say, so like AWS, so like Kubernetes cloud, no, what was it? ECEKS, which is Elastic Kubernetes Service. This EB is for cloud containers. There's no such thing as a cloud container, right? Cloud servers, I think. I think it's for server orchestration. Infrastructure management service. Right, so handles deployment and scaling for web applications. Beanstalk helps automatically manage my God, I can't speak. AWS services, set up configuration, scaling, and provisioning. Okay, so Elastic Beanstalk supports many platforms such as interesting web what service? Is there a web orchestration management service? I can't spell orchestration. Where is it? Infrastructure management service, my bad. So it's a web infrastructure management service. Okay. So let's try to remember this. 1 second.
Hey,
What was that? Web infrastructure
no,
management
my
service.
dad came out of nowhere, just asking me to switch off the TV.
Pretty fast, man. So Elastic Web Beanstalk is a web infrastructure management service. Okay. So for example, so let's try to remember this. It's a web infrastructure management service. Okay. Web infrastructure management service. So EB is a web infrastructure management service. Elastic Beanstalk is a web infrastructure management service. Damn, I can't fucking pronounce words. Elastic Beanstalk is a web infrastructure management service. That's what it is. So let's say Elastic Beanstalk is a web infrastructure management service. So let's copy this, and I'm just going to highlight this part, which is it's a web infrastructure management service. Okay. Elastic Beanstalk is a web infrastructure management service. So that's what EB is at the end of the day. So for example, let me for cloud EB. So let's call it Elastic Beanstalk. Let me just expand this real quick. Let me just close this on the side further. Okay, so EB. And apart from that, what do we have? CloudFormation. So we talked about CloudFormation, right? How it automates certain cloud pipelines using wait, CloudFormation is not infrastructure as a service. It 1 second. Right. There's something that on Terraform, and we have Terraform. Where was it? CF CloudFormation. So this is CloudFormation. Yeah. So it makes it easier because you do not have to configure the resources individually. So it's obviously like infrastructure as code, right? Then it handles the config and provisioning of the resources described in the template. So it's obviously infrastructure as code. That's what it is. Copy this. And copy. And say for example, CloudDB. And it's also take CloudFormation. Boom, just like that. Okay. So second recap, we have what CloudFormation helps to automate resource provision. I'm pretty sure that's what it is. Yeah, there we go. So we have the answer. And just close this real quick. Infrastructure management service. Boom. And networking, right? So we have different types of cloud. So the way I see it, okay, so we have the what do you call it? The actual cloud, and then we have subnets, right? Subnetworks within it. So each of these have like different sets of like permissions. For example, private VPCs, subnets, right? So that these are used to private subnets are used to keep like things like databases, and public subnets are basically the resources that the public is able to access, like, you know, for example, the actual websites, you know, web pages and all that. So let's say AWS networking. So let's say for example, let's go on in connectivity. Let's see. So this is like the internet gateway. So this is what people. So there's this thing called access control list. Okay. So think of this as the cloud. Okay. This is the cloud, and there is a access control list, which means in this list, right, there's either approved, right? So let's just call it true and false. So approved list, people are only allowed in if anyone is not on the approved list, right? Access control list, approved list, then they won't be allowed in the firewall in the first place, right? Especially in like very secure instances. So it's all on a access control list basis, right? So this is traffic allowed by an internet gateway. So public traffic can be allowed into your VPC, right? So it's allowed, but then it depends on how certain access control list people are allowed for certain resources. So virtual private gateway is used to access private resources in the VPC. So there's the internet gateway, right, which gives you access to the public cloud, right? Virtual private cloud, okay. And then within that, there's also another private gateway which gives you access to another subnet, which is a private subnet. right? So let me get this doubt clarified, okay? Let me say, so within, okay, so within a VPC, there's private subnets which have private private gateways, which are private gateways, VPGs, which monitor ACLs to allow / deny access, question mark? Not quite, okay. So VPC is a logic isolated network within AWS that you can control. Private subnets, these are subnets within VPC that you, okay. So private subnets do not have a VPG, okay. Private subnets do not have a VPG, interesting. ACLs control inbound traffic, inbound and outbound traffic at the subnet level, but do not monitor anything. They simply allow deny based on traffic rules. Interesting. If private subnet need internet access, you typically use a NAT gateway, network address translation gateway, which allows outbound traffic while keeping inbound traffic restricted. Private subnets do not have a VPG unless you have explicitly set up a VPN connection with a virtual private gateway. Okay. Private subnets do not have a VPG. Right. Okay. I got it. So you need to have so from what I see here, okay. So from what I see here, we have a VPG, okay, unless you explicitly set up a VPN connection via a virtual private gateway. So obviously, like if you have explicitly set up a VPN connection, so then via a virtual private gateway, then it will have a virtual private gateway. But private subnets itself do not have one. That's what I'm saying here, right? Okay, cool. So do not have a VPG. ACLs control inbound and outbound traffic at the subnet level, but do not monitor anything. They simply allow or deny based on traffic based on rules. Interesting. Outbound traffic at the subnet level, but do not monitor anything. They simply allow or deny traffic based on rules. Interesting. Okay. So subnet level, but do not monitor anything. So okay, so they just block or let people in. That's all it does. Doesn't really monitor anything. But in the private subnets need internet access, you can typically use a network address which allows outbound traffic while keeping inbound traffic. Okay, so you need a NAT gateway. So you need a NAT gateway in order to allow or deny which allows outbound traffic while keeping inbound traffic restricted. In order to allow outbound traffic to enter. That's what it is. So now let's move on to the next one. Direct connect. So this is lets you make dedicated private connection between the data center and the VPC. Okay, what's your private cloud? That's fine. Okay, this is something that I need to come back to because it didn't quite go in my head. But subnet and access. Let's see. We have private subnets, public subnets, and what else? Yeah, public subnets. Again, public resources, public subnets are in the public subnets, and private resources are in the private subnets, like databases. See? So network traffic in a VPC request data are sent as packets. A packet is a package of data sent over a network or internet. It enters the VPC through an internet gateway. Before entering a subnet, it checks for permissions. Who sent the packet? How will the packet communicate with the resources in the subnet? Right. So we have access control lists as well. So they allow or deny access to certain resources. So there's a firewall that controls the traffic, inbound and outbound. It controls the traffic at the subnet level. The ACL texts and controls the packets. The packet is on the approved list, they will pass through. However, if they're not on the list, they will be denied access. Interesting stuff. So let me get this straight. So these are obviously packets of data. That's what it's saying. And it's sent over the...
Hold up.
Okay. Enters the VPC through an internet gateway. And it's who sent the packet and what will it communicate with. right? So obviously it's going to be listed. And what else do we have? Access control lists, like I said, okay? So it controls the traffic both inbound and outbound, okay? It controls the traffic at the subnet level. At the subnet level, this is important because it does not do and monitor anything beyond the subnet level. The ACL checks and controls the packets. If the packet is on the approved list, it will pass through, yes, obviously. And however, if they are not on the list, they will be denied access, simple as that, okay? Not on the list, and they will be denied access, just like this, okay? So we just copy this, and let me just say cloud and network traffic in a VPC. Okay, so let's go on to global networking. Domain name system, so obviously we know what a DNS is, right? Pretty fucking simple. Route 53 is AWS's way of routing DNS web services. It is a AWS's way of routing applications. So route end users to internet apps hosted in the AWS. So basically AWS's DNS is called Route 53 apparently. So Route 53 connects users and their requests to AWS resources. So AWS's routing DNS system is called Route 53. Yes. Yep. Okay. So let me just type this out. So let's say cloud. AWS's routing system, DNS system is called Route 53. That's a cool name to give it though. Like instead of calling it a DNS server, you call it Route 53. Okay. Manage DNS records. You can register new and transfer domains with Route 53. You can manage all of your domain names from Route 53. Okay, interesting. So you can register new and transfer domains. Okay, it's also pretty cool. So let's say, for example, just grab this and paste this here. Paste that there. Route 53 and AWS CloudFront can be combined to deliver content. Interesting. So from the website application, Route 53 uses DNS resolution to identify the IP address. The data is sent back to the user. The request is sent to the nearest edge location to the CloudFront. CloudFront connects to the application load balancer. Load balancer sends the packet to the EC2 instances. Okay. Right. So Route 53 uses DNS resolution to identify the IP address. The data is sent back to the user. Okay. I gotta take a note of this. Why is my head so trippy right now? Bro, it feels like my head's fucking spinning right now, bro. I don't know why. Cloud. It uses AWS Route 53. So obviously you enter, resolution to the IP address. Data is sent back to the user. User request is sent to the nearest edge location, right? Through the CloudFront. So that's this. And it sends it to the application load balancer. The load balancer sends the packet to the EC2 instance. Okay, so that's pretty cool. So pretty much, let's try to draw this. Okay, so pretty much we go from here. Okay, so you enter Route 53. Okay, so you enter Route 53 to identify the IP address. Okay, this is DNS resolution. So data is sent back to the user. Okay, data is sent back to the user. Okay, the user request is sent to the nearest edge location. So sent to the nearest edge location through the CloudFront. Okay, through the CloudFront, and then CloudFront connects to the application load balancer. So it takes you to the load balancer, and from the load balancer, it pretty much application load balancer sends the packet to the EC2 instance. That's basically this one where the actual application is running, right? So pretty much Route 53 sends a request back to the user, and sends to the CloudFront. Okay, CloudFront sends it to the CloudFront connects to the application load balancer. Okay. Once it connects to the application load balancer, it will send the packet to the EC2 instance. Okay, so it is sent back to the user. Why does it send it back to the user? Identify the IP address. So this is based off. I think this is based off ACLs. Question mark. So let's say this is based off ACLs. Yes. Not exactly. Here's how it works. DNS resolver with the IP address of example.com, right? Okay. Could be an ALB, application load balancing, EC2 or CloudFront distribution. The user's request is then directed to the IP, right? And ACL at the subnet level and control which traffic is allowed or denied in the VPC. They do not influence Route 53's DNS resolution, but can block or allow network traffic at once the request reaches the VPC. Right. Okay. Cool. Interesting. Cool. Interesting. So we just copy this. And okay, so you can see that this is a space resolver. It queries Route 53 for the IP address to example.com. Checks its DNS records. Did I do that?
Yeah.
Yeah, so it's pretty much like a, how do I explain this? It's like saying, hey, so it's like saying, hey, so so you, okay, you are a computer, okay? Think of it like you are a computer, okay? So this is you. Interesting person, isn't it? So this is you, okay? You wanna get in my castle, okay? You wanna get in my castle, but except, okay? Except when you wanna get in my castle, there's one little term, okay? So I need to check, okay? I need to check if you are someone that I can, let in my castle, okay? So first of all, because I can't let an intruder into my castle, we're the idea, okay? So first of all, what I do is I basically run you through a CloudFront. Sorry, what was it called? I keep fucking up. Route 53, so it's like a domain name system. And then once it's done, okay, what I do next is I basically send you to this thing called a cloud what's it called? I keep fucking up for some reason. Route 53, yeah, so CloudFront, right? So I send you to a CloudFront, okay, and the CloudFront, okay, sends you to the application load balancer to make sure like it's not fucking up with this. What you're sending is not like what your intrusion doesn't fuck up the application, my castle, right? So once you come in here, okay, the load balancer, you pretty much get redirected to the actual resources, okay? So you get in the castle at that point. So to get there, right? You need to go through different layers. So the Route 53 is like the routing, okay? So I mean the DNS, okay? And then it's routed to its location via CloudFront, okay? So it pretty much routes you to the nearest location, and then it connects you to the load balancer, okay? Load balancer is obviously to make sure the application doesn't fuck up because of your request. So ALB routes traffic to the EC2 instance, right? So then ALB routes, so the load balancer will send you to the actual data, right? So EC2 responds to the requested data, exactly. So EC2 is where everything is, right? All these, it's called elastic compute, okay? So everything is on EC2, except to get there, we need to make sure you don't fuck up the systems. So to make sure that you don't fuck up the systems, we're going to send you to a process checking using Route 53, okay? So it pretty much redirects. So it takes who you are with the IP address, okay, and then it redirects the domain, the DNS redirects you to CloudFront, okay. CloudFront connects you to the closest location, and then once that is done, CloudFront sends you to the application load balancer to make sure your request is not going to fuck up the whole system, and then the application load balancer, once it ensures that, will send you to the actual data, right, to make sure everything's going safe and smooth. Understood? I know, is it kind of boring? Should I make it more entertaining? I know I was yapping for too long.
Yes.
Okay.
Put some brain rot.
Alright. Let me activate the brain rot real quick, okay? First of all, we have Mr. Google Global, alright? He's with a PD costume, he's got a big beard, right? But then this is my castle. This is my castle, okay? So my castle, I got my holes in here. You really? I got my holes in here, okay? This is my holes, okay? I got my holes, you know what I'm saying, son? Okay, so the thing is, my holes are in my castle. But you with your big, you can't enter, bro. You know what I mean? You're gonna take my clothes, alright? So what I gotta do is I gotta make sure I put some guards in front, okay? First of all, I put some guards in front. So this guard, What's wrong with bro?
Yeah, he's just a stick, okay?
Yep, this basically, so I gotta make sure this guy, right? I gotta make sure this guy checks who you are.
Just
Okay.
don't say.
So the thing is, okay, so first of all, this guy needs to check you who you are, okay? So you're gonna have this thing called a signature, okay? So let's just call it sign, okay? So once you come in with this sign, okay, what happens is and like this guy is gonna be like, oh, you know what? Okay, okay. So then he's gonna look at your sign and just be like, oh, okay. So then he's gonna send it to another person inside, okay? So another person inside saying, hey, this guy wants to come in, okay? So now this CDN guy, okay, CDN. So now this guy is also going to check who you are using your sign, okay? Except this guy is going to make sure, okay, so once this guy approves, right, it's going to send it to the CDN, and then once the CDN checks your request, right, it's going to send it to another layer, okay? It's called the, the load balancing, okay? We'll call it ELB. So load balancing, make sure like your thing doesn't, your sign, your request does not like break the whole application. Okay, break my castle, bro. Okay, so your big D doesn't break my castle, bro. Okay, so if your castle, if it doesn't break your big dick doesn't break my castle, and I know that you're safe enough to enter into my castle and not steal my hoes, then yes, I will let you in my castle. Let you have some time with the hoes and then go. Okay, that's what it is. Oh my god, that was such a brain dump way to put it. Bro, I have low energy today for some reason. I don't know why. But anyways, like I said, okay. So there's this thing called SQL, okay? SQL and NoSQL. I think I've explained this earlier, okay? So NoSQL and SQL. So there are two different ways of saying, hey, store data, okay? For example, if the data is complex data for complex data use cases, you need to go with SQL, okay? But for simple use cases, you can go with NoSQL. Except that NoSQL databases are generally faster, but SQL databases are generally slower, but they're good for complex complex systems, which require like foreign keys and bindings, right? So like for those kind of scenarios, like if you want to bind your, I don't know, like your dog with like another man's dog in some way because they're related by, I don't know, ancestry or some shit, you have this thing called primary key and foreign key. So you share that foreign key with like a sub table, right? So if they're like matching, then like, you know, you get a point. So if there's multiple different tables you gotta like associate the dogs with, then yes, you gotta use SQL. So SQL is better for that. But if that's not the case and you don't really have, if your dog doesn't really have any friends, I'm just, oh my god.
No.
If that's the case, then you can go
Sad
with
dog,
NoSQL.
sad dog.
Yep. The dog has lost his dog. It's gonna go be like, I just lost my dog. She was not funny, man.
I just lost my dog. Babe.
Bruh. Damn. Anyways, instance store provides us temporary storage. So for example, instance store means it's like the amount of time it takes for you to bust a nut, right? It's instant, right? So it's like how long can you store your nut in your nutsack? What was that? Okay, that shit was not funny. That shit was just gross. Fuck. Alright. So basically, it's just like how long can I keep my nut in my nutsack? Okay, that's what it is. So let's just say cloud. Let's just call it instance stores. Instance store provides temporary storage for EC2 instances. Okay. So let's go on to Elastic Beanstalk. So I think I've explained what this is, right? So sorry, Elastic Block Store. So there's this thing called Elastic Block Store, okay, EBS, and there's also this thing called EFS. Okay, this is a file system. This is a block store system. So everything in this, like it says, everything is stored in the form of blocks. Okay, so blocks are basically data. Like there's three parts when it comes to blocks. There's data. Okay, there's metadata. So I'm just gonna call it MD, and there's also keys. Okay, associated with each of these data. Okay, in block store. So the data could be any type of file. Okay, so any type of file, which is also having the, what the fuck was it? What did I draw right here? Metadata, right? So metadata, and metadata is like little information about that piece of data that you appended, and a key to make sure like it doesn't get fucking lost in Narnia, right? So that's what blocks, storing in blocks means. Okay, so blocks of data. So it's stored in this thing called Elastic Block Store, and there's this thing called Elastic File System, which I honestly don't know the difference between. Okay, so Elastic File System, I think it's like a file system for this block store. I think, I don't know. So I think you store all this block store data in this file system, right? So I think it works like that. So the good thing about EBS is that it takes only like the new data, so it makes sure like duplicate data is like not overwritten, right? So the good thing about EC2, sorry, Elastic Block Store, is that it avoids overwriting. Okay, so now let's go on to S3, simple storage. Now simple storage is just simple. Okay, so it's for like simple, like storing simple stuff. Okay, so it takes any type of file. Okay, you can set access permissions to a file, and it is object level storage. So for example, let's take this for example. So this is for example, oh wait, I fucked up here, my bad. So object level storage is basically this. Okay, I fucked up here. Okay, so AWS, so simple storage has object level storage, and object level storage is basically the one that takes how to explain this, the one that takes a data, metadata, and key. Okay, so let me just grab this real quick. So we have object level storage, right? So object level storage, and we have what else? The object level storage has data. Okay, data. We have metadata, so let's just call it MD, and we also have what? The key. Okay, so let's call it like this, because S3 is the one that contains that. Okay, simple storage. Okay, it's a simple storage service, so it's okay for uploading any type of files, for any type of file. Okay, so you can set access permissions to a file as well using S3. Okay, so let's just make note of that. So for example, cloud simple storage, so it says S3. So yep, there we go. So now we have storage classes, so different storage classes, which I do need to dive deep into. So let's say different storage classes under S3. Cool. Okay, so when it comes to the next part, what we're gonna do here is probably, so yeah, these are block stores. So for example, you store everything in blocks and store it as objects. So this is like everything stored as objects, right? So pretty much, let me make sure like I know the difference between these two. Data does not suffer loss, degradation, or corruption for a very long time. Data can be modified, data cannot be modified unless pre-uploaded, right? So EB stores data as blocks, and this stores as objects. That's the only difference. Okay. So S3 stores as objects. Yep, there we go. So let's grab this, revise this, and data stores as blocks, as objects. Store block can size up to 260 terabytes each. Individual object size can go up to 5,000 gigabytes. I mean 5 terabytes. Faster performance in S3. Does not suffer data loss. Okay. It can be modified. It cannot be modified. Okay. Okay. So let's get the main factors. Okay. So let's say cloud S3 is faster. EBS is faster, but S3 is does not suffer data loss. Does not suffer the data loss. EBS stores as blocks. S3 stores as objects. And what else do we have? Oops, fuck. Data. EBS data can be modified. S3 data cannot be modified. Okay. So from here, let's go to Elastic File System. So I'm pretty sure everything is stored in the Elastic File System. So data is okay. So let me try something here. Data in EFS is accessed via file paths, and scaling AWS EFS does not. What applications? Disrupt. I'm pretty sure it's disrupt. Let's see if it's correct. Because scaling elastic file system does not disrupt application. There you go. Yeah. Yeah. Okay. So EFS is a file system. Data in EFS is accessed via file paths. Compared to AWS and save data. I mean, right. Okay. So EBS stores data in one availability zone, but this stores saves the data in many availability zones. Scaling EFS does not. Right. Okay. So let's try to remember this. EW. Okay. It is ideal if many services need the same. Okay. Right. Okay. So we just copy this part and say, for example, right here, EFS, right? So EFS is a file system. Data in EFS is accessed via file paths, and compared to EBS, EFS saves the data in many availability zones, right? So apart from that, we also have EFS does not disrupt applications. So I should say not disrupt applications. It is ideal if many services need to access the same data at the same time, right? So for example, let me just copy this and say, for example, cloud EFS is better for EFS stores data in many availabilities, right? So it's better for accessing data. It's better for instance of many services to access data at the same time. Many services to access data at the same time. Okay. So apart from that, relational database service. So it's everything is like relational. So it's like SQL, right? Amazon's way of sort of presenting this is obviously using Aurora. So it's like their own way of sort of presenting a relational database. So that's what Aurora is. Okay. So this is AWS is RDS is relational database service. We know that. Okay. So DynamoDB on the other hand stores data in a non-relational format. For example, everything is sort of key value pairs, right? So key value pairs, exactly. So non-relational is key value pairs. And the structure types of the non-relational databases is key value pairs. Data represents an item, and the data value represents the item attributes, right? So each item can have different attributes. You can remove any attributes from any item at any time, right? So example of non-relational database data. Okay, so pretty much everything is under like data, like attributes as attributes under data. So it's like unlike MongoDB has everything as objects though. This is just like everything is in data. So name is in data, coefficient is in data, this is in data, and they're all binded to IDs, as you can see. So different IDs, different data right here. So let me just take a snap of this. And non-relational database with key value pairs represents an item. Data value represents the item attributes. Each item can have different attributes, facts. You can remove any attribute from any item at any time. So example, okay, so let me just copy this. Let me just grab this real quick. And let's say, for example, cloud, and it is a non-relational database, and boom, just like that. NoSQL or database, so non-relational NoSQL database, that's what it is. What else do we have? So it supports complex data, supports simple data, and faster than AWS RDS. Expensive, 100%. So NoSQL approach is obviously like, see, stores data in documents, cheaper than RDS, faster than RDS, supports simple structured data. This one can take complex data with complex relationships. Redshift is a data analytics warehouse, database migration service. So that's for like people who want to combine one database to combine multiple databases to one. So difference between RDS and Dynamo. So apart from that, database migration service and combined multiple databases into a single one. Yep, there we go. See if the answer is right. Yeah, correct. So now, okay, so now let's move on to additional DB services. So this is MongoDB's document DB, so it stores data like MongoDB, right? So, right, document DB stores data as MongoDB. Document DB stores data. So document DB stores data like MongoDB. So for example, cloud document DB stores data like MongoDB. Okay. Neptune is a graph database service. So cloud AWS Neptune is a graph database service. Okay. Quantum ledger database. Interesting. Managed blockchain. Elasticache. So it stores cache, I'm pretty sure. Caching layer stores a part of data. Accelerates application performance. It improves read times of database requests. Redis and Memcache are supported with okay, right. So AWS Elasticache is used for caching. So it's like it's storing data temporarily to improve performance the next time. That's what it is. And this is the Dynamo accelerator. So this is something that I need to like properly refer to again, not just skim through. Refer to this again. Okay, so we have the link right here. And cloud security. So MFA, multi-factor authentication, we know what that is. So this thing, right? Okay, so this is kind of fun. Okay, so we have a shared responsibility. So it's like Bezos thing. So this is Bezos. Okay, this is Bezos with a bald head, bro. Here, okay, let me draw Bezos and let me draw his like Lamborghini. Okay, can I hear you? Oh shit, my headset's going off. But let me draw Bezos' Lambo. Okay, this is Bezos' Lambo. This is his big ass tires. Okay, this is Bezos and his Lamborghini. So first of all, when he pulls up in his Lambo, he's like, hey bro, I'll give you cloud security, but you need to make sure that it's part of your responsibility as well. So then this is you, okay? You with your drippy shoe, boy. What the hell, nah, bro? Rectangle shoes, bro. It would be so fire if we had rectangle shoes. I mean, like triangle shoes, bro. Hell, nah. This shit look like a samosa for real. Okay. What the fuck is wrong with bro? Is he also Fent or some shit? Anyways, so Bezos is basically telling you that it's a shared responsibility for you to use his platform properly in order to give your client a cloud security, right? So for example, like over here, that's what he's saying: single shared responsibility model, multi-factor authentication. Okay, so that's like, you know, TPs and emails, and identity and access management. So you have a root user. Okay, root user is like the mama. Okay, the mama gives birth to unit. Okay, that's fucked up, my bad. So mama gives birth to smaller children. Okay, so this is the mama is the root user. Okay, mama obviously has control over the family. If one of these fucks violate mama, then mama can pretty much just fuck you out. Okay, so kick you out. Okay, so first of all, as you can see, this is the children under mama. Okay, so this is the root user. Okay, these are the like normal users. Okay, so normal users, each of them have different permissions as when it comes to the family's inheritance. Okay, so some guys will be given the family BMW. Okay, and some guys will be given the family's house, and then some guys will be given the family's diamonds and jewelry and other shit. But not all of them will be given everything. You know what I mean? But if you want to give each of these motherfuckers something in common, you create this thing called an organization, okay, or a group. Okay, so in this group, everyone in this group, okay, so let's say wait, I'll just call it we, H, okay, so that's for Hindu. Okay, so pretty much all of us, right, we're given shared so it's like shared permissions in this group. Okay, organization. Okay, so that's what it is. Okay, so organizations and access management once again. So security policies. So let's go for user access and what else? So we have the root user and we have the users under it. Okay, so that's what this is. Okay, so I am users and policies. So policies are like different conditions that you're going to give for especially databases. So if you don't want everyone in their mother to be accessing your database resources from everywhere in the world to possibly exploit it, you want to give it certain rules, like policies like this. Okay, so it's this thing called cross-origin resource sharing, where you only allow certain IPs to access your database to avoid any problems, right? So you see, once again, groups, right? If shared permissions will be granted through groups. Okay, so as you can see right here, roles, right? So temporary access will be given through roles. Okay, multi-factor authentication through mobile numbers or messages or emails. Okay, so organizations, once again, container for your AWS accounts, and it comes with an organization root user by default. It allows you to manage permissions of your organization's account, and permissions in AWS organizations are controlled by service control policies, so SCPs, and service control policies, right? Interesting. What? Okay, so service control policies, okay. Organizations are controlled by service control policies, right? Okay. Versions of your organization account. Right, okay, cool. Let's take a snapshot of this. So what I do here is container for your AWS account, and it comes with an organization root user by default. It allows you to manage permissions of your organization's accounts, and permissions in AWS organizations are controlled by service control policies, and SCPs allow you to restrict, so service control policies allow you to restrict AWS resources and services from each account. Okay, so this is the daddy of the account. Okay, for example, the papa of the account. Organization. The papa of the accounts. There you go. Okay, so organization root user by default. So organization root user by default. It comes with an organization root user by default, and cloud compliance. Let's see what this is about. So we have artifacts and reports, and allows you to manage accounts. Manage permissions of your organization account, but it allows you to manage permissions of your, yeah, right. Okay, my head's all over the place. I gotta fucking lock in. I don't know what's up with my head right now. It's like fucked up. It's like, I don't know, man. Okay, so what if I make this a little fun? Okay, what if I make this a little fun? So let's say Lambda, right? Lambda and DynamoDB. Okay, so obviously you know, sorry, Lambda and CloudWatch. Sorry, Fargate. Okay, so it's called AFG. We know that this and this, okay, this is serverless and this is serverless too. Okay, but this is a container service. Okay, so this is this takes containers for large applications, just like this guy right here. This is for large applications. Okay. So it containerizes these large applications, and both of them are serverless. Okay, no server. Okay. Block store. Okay, block store stores everything in blocks, and in S3, right? S3 stores everything as stores any type of data, and all the data are stored as the objects, right? In objects we have data, we have the metadata, and we have the keys. Okay, for these data. Okay, they're all stored in S3, and this is simple storage. And we have block store, which stores everything in blocks, and it's much better for more complex stuff, right? So apart from that, we have CloudWatch, which watches over your resources and helps you set alerts. What else do we have? Let me just skim through it and try to oh yeah, we have subnets, which are subnets within certain balls within the cloud. Right, so we have the private cloud and we have the public cloud. Okay, public, let's just call it PB. Okay, public cloud. Okay, private cloud and public cloud. So private cloud is for things that need to be kept secure, like databases. Public cloud is for anyone in their mother, just like Dinet and his wiener. Was that funny?
What?
That was so loud, bro. God damn. Okay. So this is Dinet. Okay. What the fuck is up with you? Turns out you're Down syndrome. Anyways. So we have this Elastic Container Service. Okay. So container means it's like a box. Okay. This is where I put all my gym equipment. I don't go to the gym. Okay, so we have the gym equipment in the container. And if you want to manage all these different gym equipment boxes, you need to have a orchestration service to manage all these different containers. Okay, so that's what Kubernetes is. Okay, EKS. Okay, EKS. And apart from that, okay, so these are all to manage different containers. Okay, so apart from that, you also need to deploy it, right? So what happens next is let's say for example, what was it? Oh yeah, so for provision, right? So provision, you can use either the CLI, which is the command line interface. We can use APIs, right? Like software APIs or, you know, endpoints. So apart from that, we also can use the console, right? So let's just call it an AWS management console, AMC. Okay. So these three can be used to provision the resources. Cool. So apart from that, Elastic Beanstalk. So this is an infrastructure, like cloud orchestration service. Okay, orchestration service. So this is to manage different cloud computers. Okay, so I think that's what the definition was. And apart from that, we have Elastic Beanstalk CloudFormation. So CloudFormation is infrastructure as code, and it has its own language. It's only supported by AWS and good for nothing else. We have Terraform, which is supported by a lot of other providers, many other providers, cloud providers, and it has its own scripting language, therefore making it valuable in different scenarios. What do you call it? CloudFormation supports YAML and JSON. Okay, YAML and JSON is what CloudFormation supports. Apart from that, what else do we have? Right, load balancing. So load balancing, we have three layers of load balancing. Okay, 1, 2, 3. Okay, so 1 to 3. First one is application level. Okay, application level load balancing. We have the network level load balancing, NLB, and we have the cloud level, CLB. Okay, so this is basically to avoid some DNet breaching into the servers with this 1,000 requests at once. Okay, it's called a DDoS attack. DNet got 1 billion bots running to destroy my servers, bro. How dare you destroy my castle, bro? You know how hard I built that shit? Man, motherfuckers. But yeah, I think I explained about on demand, right? So that's when you pay when you just need more HUDs, right? When you need more HUDs, you pay. That's on demand. If you need to reserve the HUDs for 1 to 3 years with a discount, then that's obviously, you know, reserved instances. And if you want a 12-month free trial, if you're broke, then we can use the 12-month free trial. Yes, sir. Okay. So apart from that, what else do we have? Messaging. So messaging, we have the simple notification system. We have the simple queuing system. So the queuing system will queue all the messages, right? Notification system will just simply fucking notify, hey, what the fuck? WTF, straight up. Okay, no questions asked. Pricing, scaling, so you can scale on demand, right? So I think scaling is one of those things that I'll get to at the last bit. Oh yeah, so there's three types of control instance, the configurations to control instance, right? We have the min capacity, okay, min cap, and we have the desired number, so let's just call it desired number, and max capacity, okay? So these are all used to control the instance capacity, okay? 3 types of configurations. So 3 types of configurations to control instance capacity: min, desired number, okay, so let's just say desired num, and max. Okay, simple stuff. So let's say cloud, let me just delete that. Min cap, desired number, and max cap. This is what we use for, let me just go back, auto scaling right here. Okay, EC2 auto scaling. We just copy that. Boom. So apart from that, we have what else do we have? Containers. Yeah, so we talked about containers, so it's obviously, you know, at this point I'm done. But infrastructure, let's see, yeah, we have a global infrastructure. In availability zones, we have different availability zones, so we have multiple data centers in certain availability zones as well, right? So in certain cases it's singular, but if you want to have everything spread out, you need to have elastic file system. So elastic block store and elastic file system, that's what differentiates them. EFS is obviously spread out across multiple different data centers across a availability zone. For example, in AWS, which is the West Coast servers, right? So this is spread out across all of them. So in case one of these servers go down, it will automatically switch to the other one, right? So that's the whole point of it. Edge locations, obviously, data centers. So the closer the data to the client, the faster the data will be exchanged back and forth, and you can have the infrastructure running near a server, on a server near you, right? Apart from that, what else do we have? Provision. So obviously we talk about provision. Storage, instant stores. So that's for instant storage. So you can just store temporary stuff on that. Storage and DBs, global networking, subnet and access. So we have virtual private, the private gate, private subnet, and public subnet, right? And Route 53 is what we use for domain DNS on AWS for every resource that's deployed through AWS, and it lets you manage DNS, manage domains and stuff as well. So it's easy, it's pretty good. You can add domains and you can manage them as well, all in one. Network traffic, so everything that enters into a subnet is packets of data. So it has everything that the user needs and who sent it, right? Access control lists, obviously lists of different people who are allowed into a certain cloud network, and if they're not on an access control list, they will not be allowed to access. But that does not mean access control list just allows or denies people at the the access at the subnet level, but anything that happens beyond is not part of that. So stateless packet filtering. So stateless will have no idea once you log in for the first time who you are next time, but stateful will make sure it keeps a understanding of who you are next time. You know what I mean? So you don't need to keep doing it every single time. Configuration. So it's obviously we have the network gateway, right? So network gateway and the network access control list within that, and then we have the public subnet which can be accessed, and that's where everything is deployed on EC2, right? So let's say, for example, cloud configuration. So let's go for this, and what else do we have? Domain name system. So DNS is the service that allows that lets someone access your website from their browser. Exactly. So this DNS is what we use. So behind every single URL, there's an IP behind it, right? So behind each of these IPs, there's also always like port numbers. So certain port numbers, if you can exploit vulnerabilities in the services that are running behind these port numbers, you can technically do this thing called exploiting, right? So for those kind of instances, you use this thing called metasploit, right? And yeah, there's various different approaches for that, but you get the point. So Route 53 is obviously for capturing who you are as getting the IP, and the data is sent back to user, and the user request is sent to the nearest edge location through CloudFront, and the CloudFront sends it to the data is requested from the the nearest edge location, and the load balancer, it's sent to the load balancer, and then the load balancer will send it to the EC2 instance to grab that data and give it back to you, because that's what you need, right? So yeah, so that's pretty much. Let me just copy. Let me just grab this real quick. So what happens here is, you have Route 53. It checks who you are, IP question mark, okay, who you are, your IP address, and then it sends it back, okay, sends it back to the CloudFront. And once it sends it back to CloudFront, what it does is it makes sure, okay, you're getting the data from the nearest location, okay, but based on the IP location. So nearest location, so it's an NL, okay, nearest location. So from the nearest location, it will send it to the CloudFront. It will redirect it to the application load balancer, and then it will make sure the load balancer will make sure that the sends it back up to the EC2 instance. So make sure everything is balanced out. So balance, bal, and it will send it to EC2 instance. Now from the EC2 instance, we'll grab this data and we'll send it back to you. That's what it is. Life cycle, right? So let's say, for example, cloud use Route 53 and CloudFront together. We are creating an infrastructure. Storage and DBs, instance stores, elastic file system, relational database system, right? That's SQL databases. Aurora is Amazon's way of SQL databases, which is technically faster according to them. And what else do we have? Redshift, a data warehouse for analytics specifically. Database migration services, right? So yeah, then data analytics, no, data warehouse, warehousing, warehouse, I think it's called, yeah, see if that's correct. Analytics service, okay. The analytics service, data analysis. Data analytics warehouse, analytics service, okay. Okay. So that's a cloud. Redshift is a big data analytics service. Cool. Alright. Anyways, database migration services. So that's for combining multiple different databases with one. That's what it is. So source and target database, that's what the exchange is going to be between databases, source and target database. So you can combine multiple databases into one, into a single one, just like this. And apart from that, we have yeah, there we go. So we have just like that. So let's say cloud, and boom. So you can combine multiple databases into a single one. That's easy. So now that we're done with this, man, trusted advisor. So this gives you auto recommendations based on different limits that you're exceeding, if you're doing things right or wrong. And CloudWatch, lets you set alerts for different resources to make sure you're not exceeding any limits. And CloudTrail gives you logs every event on the cloud as a trail. So what else do we have? DDoS, which is distributed denial of service, but distributed. So that's what a DDoS attack is. So it's distributed across multiple different computers. Monitoring and watching. So CloudWatch, CloudTrail, Trusted Advisor. So Trusted Advisor is a AI-based tool that analyzes things. What else do we have? Pricing model, free tiers, and billing dashboard. So obviously consolidated billing. That's saving everything together, I think. Oh yeah, everything's coming under one bill, right? So many accounts, one bill, and you get discounts in return as well if you get it like that. Managing bills is the core of consolidated billing. Yeah, many accounts, single bill. So that's what consolidated billing is. Consolidated.
You can hear me?
Billing.
Yeah.
Many accounts, one single bill. What else do we have? Budgets.
Give me a sec.
Budget lets you plan cost, usage, cost, and instant reservations. Information in AWS budget is updated 3 times a day, right? So, right, okay. Let me just grab the important stuff here. Let's say, for example, 3 times a day. Create custom alerts and budgets. You see alerts to one user, exactly. So, say, it forecast, right? So, plan usage, plan usage, cost, and instant reservations. Information in AWS budget is updated 3 times a day. So 3 times a day. So updated 3 times a day. And custom alerts in budgets. Custom alert. Use the alert to warn you if you surpass the usage forecast. Right. So yeah, that's pretty much budget for cloud services. Budget lets you compare actual versus budgeted use, and it enables you to compare budgets between budgets with many dimensions. Okay, so so we have quick estimate. Okay, show what's budgeted use into many dimensions. Okay, so it tells you like in 3 times a day, but